Hey guys, more Blakey here and welcome back to another tutorial. Today I'm going to be showing you how we can make a 2D infinite runner where the player dodges obstacles and will end when the player hits an object. So let's get started. So in this scene, as you can see, it is extremely simple. All we have is a main camera. We've got a floor game object that just includes a box collider, and we've got a player game object. This game object has a sprite renderer, which is this little white cube here. We've got a rigid body 2D component and a box collider 2D component. And preferably we want this player to be on the left side of the screen, so it gives the player enough time to see where the obstacles are coming from and dodge them accordingly. So the first thing that we need to do here is make a player movement script. And what you think we're going to do is actually move our player forward, but we're not actually going to do that. And the reason for that is that we always want the player to be relatively close to the center point of the scene, which is 0, 0, 0. Because if we're making an infinite runner and you've got a player that has a really good score and they've gone really far away from the center point, then you get something known as floating point issues, and that's when you start getting bugs in your game, or you might start seeing some lag or something like that. So we always want to keep the player close, and what we do want to move is the obstacles. So we're going to spawn in obstacles on the right off screen. We're going to have them move towards the left, and then when they go off screen again, we can despawn them, and that means we're never going to get up a big cluster of game objects or ever have too much lag. Therefore it truly would be infinite. So the first thing we're going to do here is we're going to go onto our player, we're going to scroll down, and we're going to type in player movement. From there we can create an ad, and we can double click on it to open it up in Visual Studio. So this is going to be super simple. What we're going to do here in this script is just add a simple jump function, and then if we need to, we will add to it later in the video. But for now, what we're going to do is public float jump. Then in our update function, we're going to check for input.get button down, and we're going to look for the jump function that Unity have built into their engine. Now we need to grab a reference to our rigid body. So I'm going to go back up to the top, and I'm going to type in private, because we can reference this directly inside the script. We will never need to see it in the inspector. I'm going to do private rigid body 2D, and we're just going to call this RB. Now we're going to find a new function that is known as void awake. And this is basically called before the start function. And this is ideally where you want to be assigning your variables. So I'm going to get rid of the private there. And then I'm just going to do RB is equal to get component. And we're just going to look for that rigid body 2D component. Don't forget to do your inside and outside brackets here with a semicolon on the end. Now our rigid body is fully referenced, and we don't need to do this in the editor. But now that we have this reference to our rigid body, I'm going to go back down into our function here, and I'm going to do rb.add false. So we're going to be adding a false from the direction of upwards. So I'm going to do vector2.up, and I'm going to multiply this by our jump float. Now, while we're here, we need to add an is grounded check, just so the player can only jump while they're on the ground. And we can do this very simply. Now, in more complicated games, you might want to use something known as raycasting, which you may have seen in my previous videos. But for something as simple as this, where they're only going to be colliding with this flat ground game object, we can just use on collision enter. So what I'm going to do here, at the top, I'm going to create a new private bool known as is grounded, bool being a true or false function. And then underneath for update, I'm just going to type in void on collision enter 2D, set the collision 2D type to other. And then I'm going to check for if other dot game object dot compare tag is equal to ground, which we're going to assign back in the inspector soon. Open and close curly bracket, and we're going to set is grounded equal to true. And now we need to do the opposite for when it is false. So we're going to do void on collision exit 2D, set the collision 2D type to other, and then we can copy and paste this code here and just set the is grounded to false. So what we're saying here, if we have just collided with the ground, then we know that we are grounded, so we set it to true. And if we've just left the ground, then we've obviously jumped, which means we are no longer grounded. But now we need to add this functionality into our jump function here. So I'm just going to do if input.get button down jump. So if we press the space bar and is grounded, then we can jump. So if we are in the air and we press space, we cannot jump. And that is all we need for now. Now, one tip from me when we're making this game is I would recommend to set the gravity scale on our rigid body to 2, as that makes our jump a little bit less floaty and gives the players some more control. So when they jump, they come down relatively quickly, and then they can continue to avoid obstacles. So make sure to set this to 2 if that is what you would like. And then we're going to set the jump to a number something similar to 130. And before we test this, our floor needs the ground tag. So let's go to tag, add tag, press the little plus sign, type in ground with a capital G, go back to our floor, and then add the ground tag. And now if we press play, whenever we jump, we get a very low jump. So we know to increase this in the inspector. So I'm going to go back, I'm going to double this to something like 300. And you can see that that is much better. And of course, you can tailor this to your game. And we even may tailor it as the video goes on. So now what we need to do, we need to define a few points for the obstacles to spawn in. And then in our script, we can randomize between a few numbers and assign these numbers to the spawn points. And from there, it will be able to randomize which obstacle comes in next. So what we're going to do here, I'm going to right click in our hierarchy. I'm going to go to create empty and I'm just going to type in spawn point. And now I'm going to give this a gizmo. So if we go into our inspector, click on this little cube here and we can just give it a red diamond. So now I'm going to have 3 spawn points. I want to have one where the player has to dodge under it. I want to have one that the player has to jump over. And then I want to have another one that tricks the player into thinking they have to jump over it. But if they do jump, then they actually bump into it. So we're going to drag this spawn point. This is going to be the one that the player has to jump over. So I'm just going to put this to something like here. Then we can just copy and paste this to about here. And then we can copy and paste it again to about here. And of course, we can test this as we play. As you can see from here, it's a little bit too high. So we can drag this down here. And we can drag this one down as well. And these are our 3 spawn points. So before we go into the code, we need to actually create the object that is going to spawn in. So again, let's right click, 2D object, sprites, and we can just choose a circle for this. We can just call this spawn object. I'm going to shrink this down and I'm just going to give this a circle collider. I'm also going to give it a rigid body 2D and I'm going to set the body type to kinematic. So it is not affected by physics. I'm going to set the collision detection to continuous and set the interpolate mode to interpolate. And finally, this object needs a script so it moves left. So let's add a component and we can just call this spawn object script. Now we can open this up in Visual Studio. So we're going to do something similar in terms of referencing our rigid body. So I'm going to do private rigid body 2D RB. And then I'm going to do RB equals get component rigid body 2D. Now from here, I'm going to do RB dot velocity. So I'm going to be setting the velocity to vector2 dot left. I'm going to multiply this by a new float known as speed. So I'm going to do public float speed, and then we can use that down here. Now we can test this by setting our speed something like 5 and pressing play, and you can see our object moves to the left. To make this a little bit easier to see, I'm going to change the color of our object and our player here both to black, just so it's a nice looking contrast, as before it was a little bit hard to see. So from here, I'm going to make a brand new script now known as GameManager. And this is what we're going to use to control the spawning in of the objects and more. So let's go down here to our hierarchy, create empty, type in GameManager, and then we can just add a component, type in GameManager again, create and add a new script, and open this up in Visual Studio. So what I'm going to do here, I'm going to use something known as an array. An array is basically a set of objects, so we can drag in multiple objects into this, and then we can access different elements inside this array. So I'm going to do public game object, and then I'm going to do these straight brackets here, so C# and Unity can recognize this as an array. Then I'm going to type in spawn points. I'm also going to add a float known as public float timer, and finally another float known as public float time between spawns. I'm going to show you how we're going to use these floats. So the first thing we need to do is set up our timer so it goes up with time. So the easiest way to do this is setting timer plus equals to time.delta time. As time.delta time is just how long since the game has started. So that timer will increase with that and will go up in real time seconds. So from here, what we're going to do is we're going to check if our timer float is bigger than time between spawns. So if the timer has reached a certain number that we have set in the editor, inside this function, we're going to create a new integer called random num, referencing random number. And we're going to set this to random.range, which is a function Unity have to pick a random number between a starter number and an end number. And these two numbers are going to be between 0 and 3. Now you may think this is going to be between 1, 2 and 3 to pick between our 3 spawn points, and it is, but it's not technically 1, 2 and 3. It's actually 0, 1 and 2. So our first array is going to be number 0, our second array is number 1, and our third array is number 2. But then you may be thinking, why do we have this third number here? Why are we picking between 0, 1, 2 and 3? Well, we're not. This random.range function cannot be this last number. It can always be one less than this. So this will be picking between 0, 1 and 2, which is exactly what we want. So from here, we are going to instantiate, which means spawning. Now we don't have a game object to instantiate here. So I'm going to get a reference from the inspector. So I'm going to do public game object spawn object. So now we can pass this in as the object we're going to spawn. So we're going to type in spawn object. Now we need to pick a point that it is going to spawn. And this is where we use our spawn points array. So I'm going to type in spawn points. So when we're using an array, we need to pass in a number here. So it knows which game objects inside the array to pick. And this is where our random number comes in. So we can just type in rand number here. And finally, we're just going to type in for the rotation quaternion.identity, which will be the rotation of the game object. Now you can see that we're getting an error here. And the reason for that is because all we've done here is reference the game object. What we haven't done is reference the position, as this right here needs to be a vector 3. So that can be simply be fixed by putting dot transform. So we're referencing the transform of the game object and finally the position. So we're spawning in the spawn object game object. we're spawning it at whatever our random number generator picks at. And then finally, we are setting it to the rotation of that game object, which will just be 0, 0, 0. And the last thing we do before we go into the inspector is we need to set our timer float back to 0 when it is larger than time between spawns. Otherwise, we will just have an infinite number of game objects spawning the minute this runs true. So right at the top, we need to set timer equal to 0. So this will run every time timer becomes larger than time between spawns. So now a few things we've got to do here. Firstly, this spawn object, we need to make it a prefab. So we can just simply drag this into our assets to make it a prefab. Then we can remove it from the hierarchy. Next, on our GameManager script, we need to assign a few things, such as our spawn object. So that can be our prefab we've just made. So we drag that in there. Next, we've got this spawn points array. This is where we drag in our 3 spawn points. So what we're going to do here on our inspector tab, let's use this little lock function to lock it in so we can select other objects here and it will stay on our game manager inspector. Now I'm going to control and select all 3 of our spawn points and I'm just going to drag them into this array here. And you can see we've got all 3 of them. You can also see it says element 0, element 1 and element 2. And finally, we need to set our time between spawns float. I'm going to set this to something like 3 and now we can test this. So I'm going to hit play here. So we're waiting for that float to go up and you can see it spawned at the bottom one. So we can jump over this and now we can see it spawned at a different point. And then we've got the top one here. Obviously, as you can see, that is a little bit too tall, so we can do some adjusting there. But you can see it is random every time. So what I'm going to do here on our spawn object, I'm going to go to our circle collider. I'm actually going to set this to a trigger. I'm also going to give it a tag. So I'm going to add a tag, type in enemy, and then I'm going to go back to our spawn object and give it that tag because we're going to be using this in the script to restart the scene. So now I want to add in the functionality to make the player to be able to slide. So then the player will be able to jump over obstacles and slide underneath them. But before we do that, I want to adjust some of the points we've got here. So as we saw, some of them are slightly in the wrong position. So this one is going to be to jump over. I want this one so the player slides underneath it. So I'm going to try around at this angle. And then we can just move this one down to here. And now what I'm actually going to do, I'm going to create an animation that we can trigger directly from the script, which is going to cause the player to slide. So on our player, I'm going to head to animations. I'm going to click on create and I'm just going to type slide. So up until this point, we have just been using a normal sprite square and we've just been changing the scale like this. This is not necessarily good practice because now what we want to do is we want to make an animation where it is shortened, but it is going to cause issues with our jumping and stuff if we handle it using scale. So what I'm going to be doing, I'm going to be swapping 2 sprite textures, one between standing and one between crouch position. So what we need to do is go into a separate arts software, any very simple one that could just handle squares. And I'm going to make one in a rectangular shape. I'm going to make one that's a little bit shorter than that. And then we can swap between these two without affecting our scale. So I'm going to head into Photoshop, but feel free to head into literally anything. Even Paint could do this. So these are the 2 sprites that I'm going to be importing. So this is the crouched one. So you can see we've got this white square here, but this is transparent. This one is going to be the full body player, which just has the full sprite taking up all of the screen. Now, the reason I've set them to white is so if we want to change the color at any point, we can. Whereas if we have it set to black, we cannot change it set to any other color. So now I'm going to import these 2 sprites into Unity and then we will carry on from there. So what I've done here is I've imported these 2 sprites right here and I've set the pixels per unit on both of them to 1000. Then what I've also done is gone to our player and I've just dragged in this player idle directly in here and I've reset the scale to 111. Next, what I'm going to do is I'm going to remove our box collider and I'm just going to re-add it so it resets the position. And finally, I'm going to set the scale to something like 0.4. And I know earlier I did just mention about altering the scale, but what is different this time is that the scale will not be changing regardless of what height we have the player. Because now we have a sprite for it, we will not need to change the scale in Unity, which means we will not be causing issues in that regard. And I'm going to show you what I mean now. So now we can head back to our animation that we've got here. I'm going to dock my project tab here. And now I can press play on this animation and I can drag in the player slide into our sprite slot. And you can see that it changes and we don't have to do anything else there. But what we do need to do is change our box collider. So I'm going to edit the collider and I'm just going to drag it down here like this. And then it will automatically go back the way it was when that animation is finished, which will be at the 1 second mark. So I can copy this and paste it at the 1 second frame. So now in our animator component, if you don't have this component, make sure to head to Window, Animation, and then just click Animator. And then with our player selected, we need to do a little bit of functionality here. So right now, if we played the game, we would just go straight into our slide animation because we don't have any other state. So I'm going to right click anywhere outside of any of the boxes. I'm going to press create state and I'm just going to press empty. I'm going to rename it idle. So this is what our player will normally look like when it's not in this crouch position, just like this. So now I'm going to right click on this entry here I'm going to press set state machine default state, and I'm going to make it to idle. And then from there, I'm going to make a transition from our idle to our slide. And now to trigger this, I'm going to go on parameters here. So make sure you're not on layers, you're on parameters. Press the plus sign and press trigger. And we can just type in slide with a capital S. And then on our transition line here, I'm going to disable exit time. I'm going to set the transition duration to 0. And I'm going to press the little plus under conditions here. And I'm just going to set it to slide. Back in our player movement script, we are going to get a reference to that animation. So I'm going to do public animator, and we can just call it anim. And then in our update function, I'm going to check for if input.get key down, and then I'm going to check for key code.left shift inside and outside curly bracket, and I'm just going to do anim, so we're referencing this animator we just made. I'm going to do anim dot set trigger, then we're going to do some quotation marks and then slide with a capital S. So that means we will call that trigger, which means it will call our slide animation, therefore shortening our box collider temporarily, which is exactly what we want. I'm going to scale up our player just a little bit here. So I'm going to set it to 0.6 on all axes. Then we can drag it up just a little bit. And now we have the freedom to do these things without having issues of animation scaling or jumping problems when changing to different animations. So now that we've done this, make sure your animation is dragged into this tab here. Now let's go ahead and hit play. Now you can see we can jump absolutely fine. And if we press left shift here, you can see we crouch into that position and the box collider follows it. So you can see we've got this object coming up and we can slide underneath it. So we can jump under this one, we can slide underneath this one, and then you can see we also can't jump over this one because we just clip it. And then the last one we have just to potentially trick players, because when this gets faster and faster, it might be a little bit more confusing to handle. So in our GameManager script here, I'm going to add a new float, and I'm just going to call this speed multiplier. And we're going to be using this float to communicate with our spawn object script here, as every time our player spawns in, we are going to use this speed multiplier to determine the speed of that object. So in our update function, I'm going to do speed multiplier, similar to what we did here. I'm going to do plus equals time dot delta time, but I'm going to multiply this by 0.1 f, so it moves at a very slow rate. And for now we can keep this public as we can see it in the inspector, but of course you can change it if you don't need that. Either way, it doesn't really matter as we won't be altering it in the inspector. So now that we have this value, I'm going to head into our spawn object script here, and I'm going to reference our game manager. So I'm going to do private game manager GM, and then in our start function I can do GM is equal to game object dot find game object with tag. I'm going to type in game manager, and then at the end of that I'm going to do dot get component game manager. So now we are finding a game object that has the game manager script, which we are going to do in the editor. And then on that game object, it has a component, which is our game manager script. So that is how we're referencing it right here. So every time an object spawns in, it will call this function. And then finally, with our speed, I'm going to add a left bracket here. I'm going to do speed plus GM dot speed multiplier. So it will be at the base speed that we've set it, but that will be added to our speed multiplier we have in our game manager. So then that means the speed will slowly increase as time goes on. So before we press play, go to our game manager, click on our tag, press add tag, and just type in game manager, then go back onto our game manager and add that tag. And now if we unclick this maximize and play and press on our game manager and press play here, you can see this speed multiplier will go up very slowly. And you can notice that even after a short period of time that they are obviously already faster. And this will only ever increase. Now for the sake of this game, in this tutorial, this speed is absolutely fine, as we're not going to be turning this into a fully fledged game. This is just to show you guys how I would do it. This is just to show you guys a simple way of making an infinite runner. But of course you can change these values in our script. If you wanted this to go slower, you could set this to something like 0.01, so the speed increase takes way longer. If you wanted it to be quicker, then you just increase this value. You could do it to something like 0.5 or something like that, depending on how you want your difficulty to scale. So now the last two things we're going to do to wrap up this video is add some functionality to respawn the player, and then finally add some UI to add some distance or some sort of high score system for the player to keep a track of their score while they play. So firstly, let's handle the respawn system. So we're going to go up to the top here and add a new namespace. We're going to do using Unity Engine .scene management. And then down the bottom here, I'm going to do void on trigger enter 2D, change the collider 2D type to other. And I'm going to do if other.gameObject.compare tag is equal to enemy. Then we're going to do scene manager load scene, and what I'm going to pass in is the scene we have but by its build index, which is 0, and I'll explain this when we get back to the editor. So back in our editor, if we go to file then build settings, you can see that all the scenes we have in the build will be here. If yours isn't, press add open scene, and the one scene we have in this game is this one that has a build index of 0. So if you had another two scenes here, they would have build indexes of 1 and 2. So you could pass in a string in our script there to pass in the scene name. But for the sake of simplicity, I'm going to do it by build index as we only have one scene. So now if we play and we end up colliding with this object, you can see the scene restarts, which is all we're going to do in that regard. Obviously, you could add things like a game over screen and more, but we're just going to be building the base functionality for the game mechanics in this video. I can do a video on a game over screen if that's something that you'd want. Let me know in the comments if you do. So before we wrap up this video, I think it's time we add some very simple UI. So I'm going to do here a neo hierarchy. I'm going to right click, go to UI, and I'm going to press text, and I'm just going to call this distance. Now, if we press on our canvas and press F to focus in on it, you can see our text value here. Initially, I'm going to set the alignment to middle and middle, and then I'm going to press T, and I'm just going to resize this to our corner here. And then on this little anchor button on our transform component, click on it, then hold Alt and press top left. And you can see it will center it to the top left, and it will also anchor it to the top left. Then go onto our canvas, set the UI scale mode from constant pixel size to scale with screen size, and then we're going to readjust our text slightly. So I'm actually going to set the font size to something like 30. I'm going to scale this up a little bit. I'm going to set the color to completely black, and why not, let's set the font style to italic. We can simply change this to distance, as we're going to be changing this in the script anyway. And actually, I'm going to set the alignment to left here. And then we can move this a little bit to the left. And then before we go into our script, we need to have enough space in our text box in case the player gets a really high score. So let's drag this along a little bit, just in case the player gets a crazy high number here. And now finally we can go into our script. So in our GameManager script, let's add a new namespace so we can reference UI. Let's go using Unity Engine.ui, and then we can get a reference to our text. We can go public text distance UI. And then at the top of our update, let's set the distance UI.text. And now we need a float that we can set this distance to. So I'm going to create a new float. I'm going to use private float distance, and similar to what we're doing in both of these, I'm going to set it to distance plus equals time.delta time. Again, you could multiply this by something like 0.5 or 0.8. In fact, let's multiply it by 0.8f so it's not exactly the same as real-time seconds. And now we can pass in this distance float. But you can see that we're getting an error here, and the reason for that is because this distance UI.text is looking for a string. And what we have here is not a string, it is a float. So what we're going to do is distance, and C# has a really helpful function called toString, which is exactly what we can do here. And that's all we need to do for that. Back in the editor, go on your game manager and just pass in that distance UI into our field here. Now, if we hit play, you can see that we do have a distance float. You can see there is a bunch of crazy numbers on the end. And also, we're not telling the player that this is actually a distance reference here. So let's make some changes. Back in our script, I'm going to set the distance UI.text equal to. So I'm going to do some quotations here, and I'm going to do distance with a colon and then a space. And then outside of our quotation mark, I'm going to add a plus sign and then distance.toString. So what we're doing here is distance equals, and then we're going to pass in that float. So now players know that this is in fact a reference to how far the player has traveled. But again, we need to solve the issue of having a bunch of those crazy numbers. So because we're not really going to be changing this float or adding to it in any way, inside our function here, they have a great feature where we can put some quotation mark, put a capital F, and then a number to reference how many numbers we want after the decimal. So I can do F2 here, go back into our game and press play. You can see we only have 2 numbers after the decimal. So when you have a float that is going to need to be changed or added to, you do not want to use this, as this is simply for display reasons. If you want to round up a float so it can be used in other floats and other mathematical equations, this is not the way to do it. But for our use case, this is perfect. So the last thing we're going to do is just something to save a little bit of space and just general good practice. So what we're going to do here is when we spawn an object in, when it goes off screen, we are going to destroy it. So we're not making a bunch of new game objects if the player gets a really high score. So what I'm going to do here is create a new private float and call it timer. Then in our update, I'm going to do timer plus equals time.delta time. Again, what we've done a bunch of times in this video is a really helpful function. And then we're just going to check if timer is bigger than something like 6. We're going to do destroy game object. You can see that when an object gets spawned in, after 6 seconds, it will be destroyed. And you can see right there, they all start to destroy. So that means we are never taking up too much space, as this is something that can be infinitely run, as they spawn in and they get destroyed. So even after 5 minutes, this would still be in the same state it was. So guys, there you have it. We have a very simple game. Now you can combine other videos I've got on my 2 channels, such as having a main menu or a pause menu script. But when it comes to making an infinite runner, we essentially have that. So guys, I hope you enjoyed today's video. I'll thank you all very much for watching. Make sure to like and subscribe if you enjoyed. And let me know if you want me to do more of these full game tutorials. I'll thank you all very much for watching, and I'll see you all in the next one. Bye.